Hello, everybody. My name is Hippokrates Pandis. I'm a VP Distinguished Engineer, and I'm working mostly on analytics and database services at AWS. Welcome to this talk, which, in addition to me, we have also Francisco Juan from Klarna, and the topic of this talk is the evolution of Redshift. Redshift is Amazon's petabyte scale data warehouse. And this talk is about the evolution of the service over the years. And I hope that Francisco will also be able to share some of his experience with the service. It has not been a smooth ride, I can tell you for sure. But I'm very happy that he's here and he can share some of his experiences with you. I've been giving this talk for over a year now, and that was the original slide I had. It was the evolution of Redshift over the past 10 years. But actually today is the birthday of Redshift. Andy announced that exactly 11 years ago, to the date, we went up there as Amazon. We announced a new cloud data warehouse. And we have been quite successful since then. You can see a very large number of customers that have adopted Redshift over the years, and they run their analytics, their business decisions based off of Redshift. And it is a very, very big service. Those are some numbers. We have gone publicly and talked about it. So today we have tens of thousands of customers processing exabytes of data daily. And we run billions of queries every day. We have tens of billions of queries every week. And for example, even this last month, we GA'd the zero integration between Aurora MySQL and Redshift. We were able to achieve over 1 million transactions per minute in Aurora, and this data to be immediately reflected into Redshift in, on average, less than 15 seconds in a transactionally consistent fashion. People use Redshift for all sorts of stuff. They don't use it only for SQL. They use it for machine learning as well. We have billions of predictions every day with Redshift. And also, one other type of application we are seeing becoming increasingly popular is around near real-time analytics, where you customers are coming with streams of data that you can load to the warehouse, use the super data type to do manipulation of semi-structured or unstructured data, and then derive actionable insights out of them. And we have gigabytes of data ingested in Redshift per second through this streaming ingestion. So it is a very, very large service and solves many use cases. And what I'm going to do in the next approximately half an hour, I will try to go fast, but sometimes I might get into too technical details. But what I'm going to try to do is paint you how we're thinking about the evolution of the system, where we are spending our investment, and what are the areas of strength, if you will, for Redshift. So we have a very large team, the engineering team. And if you squint a little, you can see that actually we are focusing our energy in kind of 5 big thematic areas. The first one, and probably the most important, and there is a reason I'm having it first, is security and availability. You, the customers, trust us. You give us exabytes of data to store and make sure that are not only securely stored, but also available for you to consume. And when I'm giving this talk, in order to make sure that everybody's awake, between those two, the security and availability, which ones do we pick? And a raise of hand. Come on. Security, yes, you are correct, Elliot. So yes, the most secure system is the system that it is down. I mean, if you don't have any other options, it's better to be safe than sorry. we have been offering industry-leading security and access controls, and we do that out of the box without asking you to pay any additional charges for that. For example, here is a list of a bunch of capabilities we have released recently, including role-based access controls, including obviously, we give you the ability to run your analytics in your own VPC. All the data is always encrypted, and so on and so forth. More recently, we released dynamic data masking. Customers who want to set up their access controls and have more elaborate governance schemes where, for example, they can say, hey, all my database administrators can see only the last 4 digits of the social security numbers, but maybe some security investigators can see more than that. And they can do that using role-based access controls and dynamic data masking. And we keep on improving on this area. And as of, I want to say on Sunday, we announced the trusted end user propagation as AWS. What that means is that now we have integrated the analytics stack coming from the BI, from QuickSight to Redshift to Lake Formation, and down to S3 with S3 grants. And we can integrate with the IAM Identity Center, and you can come in with your Azure AD, your Okta, your Ping, your identity, IDP, and we map the groups that belong of your organization, your end users. We map them to roles in Redshift, and you can go and set up your access controls, not only to Redshift, but also in Lake Formation and in S3. This has been a constant request from our customers. If you have been using Redshift over the years, creating many IAM roles was challenging, especially as the organization was growing, your organization was growing, and this is providing a very elaborate solution to this challenge, to this problem. In the areas of availability, we keep on pushing the envelope. And as of, I want to say a couple of months ago, we GA'd Amazon Redshift Multi-AZ. The way it works is we have literally 2 compute environments in 2 availability zones that you provide. During health state, we give you the throughput of the 2 engines. We double the throughput of your warehouse. And in the very remote case that there is an event in the availability zone where your primary compute environment is, we very quickly fail over to the other one, maintaining availability for your system. And we GA'd this capability over, I want to say, a couple of months ago. And by doing so, we also elevated the SLA we offer for multi-AZ Redshift to 4 nines of availability. So the second area we're spending a lot of our energy is around performance. It's kind of the DNA of the service, performance, and we are always trying to push ourselves to offer better price performance for you, the customers. And this is the kind of the most recent measurements we did coming to reInvent this year. We have rolled out a bunch of capabilities, including, for example, on Redshift serverless, we started rolling out Graviton 3 processors without you having to do anything in your serverless applications. You just start getting faster. A lot of internal improvements on the engine, on the encodings, all sorts of stuff. And we recently compared ourselves to the out-of-box performance compared to other popular cloud data warehouses. And we can see that Redshift offers between 40% all the way up to 6 times better price performance than the other popular cloud data warehouses. In order to, this is probably the more technical slide I have, is in order to understand what is Redshift, how does it work, we can actually take a peek under the hood and try to understand a little how the system is implemented. Redshift is a very, very simple system. It consists of 2 layers, the compute layer and the storage layer. We have disaggregated storage and compute. And on the compute layer, we have 2 types of execution nodes in your MPP, your parallel database, data warehouse. We have one type of node, which is called the leader node, which is where you connect with your typical favorite tool of choice, JDBC or DBC, data API, you name it. And the leader is the brains of the system. It has statistics, it has the catalog, it knows the distributions. And what it does is it takes a statement, it takes a query, it optimizes and generates what in database lingo we call it distributed query execution plan, which is actually the physical plan where it says, we believe that this is the optimal way to execute this query. There are some interesting properties in Redshift. For example, if you have joining two tables that are distributed on a key that you are using for the joins, say you have customers and orders and both of them are distributed on the customer ID, then we do something that it is quite efficient. We join these things without having to shuffle any data. We call them collocated joins. It's a very efficient way to join data. So we do all these things, and then we do one thing that it is very interesting and unique in the industry of cloud data warehouses, which is that after we generate this query execution plan, we literally open a file and printf C++ code in a very efficient C++ code, which it tries to execute this query as fast as possible. We take this executable, we compile it, we send it down to the compute nodes, and then we are off to the races. The compute nodes start pulling data from the assigned data partitions they have, and they use all sorts of tricks there. You can read in the database books, like min-max pruning, vectorized scans, scanning data from local attached SSDs, using encodings that allows us to operate on compressed data. All the tricks in the book in order to make this processing as fast as possible. So that is the primer. By now, you are experts in Redshift. If somebody asks you that, then you're already an expert in Redshift. Being in the cloud allows us to change the rules of how we have been thinking of design of database systems. I'm coming from IBM. I used to be at DB2, and back then, you had a fixed set of resources where you had to optimize your query execution. But in the cloud, things are different. For example, one of the things that may have noticed in the previous slide is that we generate C++ code that we have to compile and send it to the compute nodes to execute. Every time I give this kind of talk, somebody raises their hand and says, hey, Ipo, don't you worry about the compilation cost? Doesn't get it in your way as you have low latency applications that are waiting for compilation? And the answer is, obviously, we do worry about it. And we do all sorts of tricks in order to try to minimize this overhead. For example, we have a small cache on the leader node of every compute environment in Redshift, which, because there is tremendous repeatability in the types of statements you are executing every day in, day out, by having this simple cache, it has a compiled cache hit rate of around 99.5%. But that was not good enough, because still 0.5% of your queries still have to wait for some seconds for the code to be compiled. In order to further improve this situation, every time we see some query pattern, query fragment that we have never seen in the fleet, in the billions of queries we are executing across the globe every day, we send it down to a compilation service. Then we have a bunch of machines. They compile the code. They put it on a global Dynamo table and a global cache. And now, the next time, every other cluster that wants to execute the same query fragment, it finds it there. By doing this simple trick, we were able to improve the cache hit rate of compiled code from 99.5 to 99.96. We improved it by an order of magnitude. And this is the things you can do in the cloud you could not do in the old school on-prem databases. And by the way, the reason this thing works is what in mathematics, I guess they call it pigeonhole principle, right? There are that many tables with 5 integers, and there are that many queries that have 1 predicate, 2 predicates, 3 predicates. At some point, you exhaust the search space of meaningful queries. Some very, very interesting things you can do in the cloud. We are actually rewriting the book of how we build databases out of that. Right. And you, the customers, do benefit from that. For example, Global Foundries is a large manufacturer that moved from on-premises to Redshift. They were able to see over a 3x improvement in their performance. They were able to load more data, terabytes of data daily, and power their analytics using Redshift. We did all these things. Redshift was the first cloud data warehouse out there, had tens of thousands of customers, performance was good. But one thing that you folks, the customers, came to us and asked us is, okay, we want to store more data, we want to elastically increase more on the compute side as well as on the storage side. Can you please do something about that? And that's what we did. Probably the biggest change in the architecture of Redshift over the past 6-7 years has been the introduction of Redshift managed storage. When we launched Redshift 11 years ago, the networks were not as fast as we wanted them to be. We had at most 10 gigabit network back then. And the storage and the compute in Redshift were co-located in the compute nodes you were buying in the provisioned Redshift environments. But fueled by the innovations that EC2 is providing us through the Nitro hardware, and now EC2 is giving us 100 gigabit networks, we were able to disaggregate storage and compute and let them scale independently. And by doing this massive re-architecture on a running fleet of thousands of customers and exabytes of data, it was a major re-engineering effort. But we are at the end of it. We are out of this thing, and now we can innovate much, much faster. For example, this is one of my favorite graphs. What we did here in the lab, we took one of the industry benchmarks, the Cloud Data Warehouse benchmark modeled after TPCDS, and we started from 10 terabytes of data in this benchmark, and we cranked it up all the way to 1 petabyte. And we increased proportionally the hardware we were using to run this benchmark. What you can see is the amount of time it took to run this benchmark. It is around the steady, around 2.5 hours. We were able to increase the data volume by 2 orders of magnitude, and the amount of time it took to run this benchmark was predictably at the same amount of time. This linear scaling to even from the terabyte scale to the petabyte scale is a very nice property. It allows you to forecast. As the data volume increases, as your user volume increases, you don't get unexpected with increased costs and running out of budget for your analytics. So we kind of addressed the needs on the storage elasticity, and then came the challenges on the compute elasticity. The first thing we did is we allowed Redshift to scale to online resize on any Redshift compute environment to online resize. And you can do that in order to very quickly fine-tune and find the right size for your cluster in order to meet your SLA for your queries. Once you find this right size, there will still be the Monday morning where all your developers, all your analysts come out to work, and they sip their coffee, they want to see the reports, they want to see their dashboards. At that point, all of them, they are hitting the environment, they are sending their statements, and at some point, the resources get exhausted. There is too much work to be done by this compute environment. In order to address this problem, what we did is we built Redshift concurrency scaling. What we did is literally an auto-scaling capability. You are still connected to one endpoint. When there is some queuing piling up, it starts bringing additional clusters of the same size, and it starts increasing the throughput of the system now linearly. And when the demand goes down, when people go for lunch, whatever, the system contracts back to the original size. We keep on evolving capabilities on concurrency scaling. We have added support for we had the reads, we added support for writes, insert copies. We just released support for create table as in concurrency scaling, and we keep on adding more capabilities there. And by doing so, we are trying to make sure that Redshift is also capable of addressing the operational data analytics workloads that we see becoming increasingly important for you. For example, in this graph, what we did is we measured the price performance of Redshift in a BI dashboard type of workload. What we did is we had a small data set, and we had an increasing number of concurrent users submitting low latency queries. What it matters in this benchmark is the throughput of the system, how many concurrent users you can serve with a fixed amount of money. And what you can see is that Redshift, in this particular case, Redshift serverless, is able to get up to 7 times better price performance than other popular cloud vendors out there. We did all these things, so we solved the problem of storage elasticity, compute elasticity of any Redshift compute environment, but then you came and told us, you know what, we really like what we have, but we have these departments that they want to operate in an isolated fashion. We want to have separate environments for my business units, for my line of business. I want to charge them back. I want to scale them, size them independently. Can you please do something about that? So over the past 3 years, we have been working on a capability of Redshift to share data from the Redshift managed storage. So you can do that. You can have a producer cluster and a bunch of consumers, and you can spin up independently either serverless or provision clusters, and they can consume in a transactional ecosystem fashion the data that are being generated by the producer environment. And all these environments, they can auto-scale independently, they can be sized independently, they can scale independently, and they can be in the same account, across different accounts, or even across regions. We have customers, such as we have large customers that they are powering their analytics. They have businesses in Europe, in India, in North America. They still want to run analytics even across and see what their operations are doing without moving the data from the country that they got generated. And they are able to do so by using cross-region data sharing in Redshift. Thousands of customers are using data sharing now. For example, Orion. Orion is a SaaS provider. It's a data as a service company. They source events from thousands of SQL Server databases on premises and in the cloud. And you can see their architecture where they are pulling the data into Redshift, and then they have consumer environments. They give it to their own customers, and they can spin up an environment and consume the data that Orion is providing to them. And we see 2 types of multi-data warehouse architectures that are being created now with the ability to have Redshift data sharing. The first one is what you may have heard referred to as the data mesh architecture, where you can have different departments curating different data sets, but they still want to have access to the data sets of the other departments. Another very popular architecture we see is the so-called hub and spoke architecture, where what happens is you have an ETL cluster where it is environment, it gets the stream of data, it gets 0 ETL, it gets all the data, does the transformation, and then creates curated data sets that are being consumed in an ad hoc fashion or for dashboarding or data scientists from separate environments. And you decouple the ETL side of the processing from the consumption side of the processing. Both of these architectures are very, very interesting and allows you to scale your analytics on demand without having to add additional load in one unique environment, creating all sorts of problems that I'm pretty sure Francisco will gonna talk about soon. And we keep on improving in this area. So as of, I'm gonna say on Sunday, we announced the ability not only to do read-only data sharing, where you have a clear distinction between a producer and a consumer, but now you can also do writes in data sharing. So you can go, spin up your Redshift environment, but if you have a very demanding ETL job, or you have a very big or a very small stream of data that you want to add in your curated data set, you can spin up your separate environment and then go back and write to the main kind of golden data set that it is being curated and managed in a central system. It allows more flexibility. It allows you to think even broadly in what types of multi-data warehouse architectures you can build for your service, for your organization. This is in preview. We are excited. You can spin up, and it is available for you today. So we did all these things. So we have good performance, storage elasticity, compute elasticity, multi-data warehouse architecture through data sharing. But you came to us and said, you know, we like what we see, but still, Redshift is quite challenging for me to operate and use. Can you please help us a little about that? So a large part of our team is trying to kind of make your life easier as database administrators or line of business users. For example, since you are literally renting some hardware, some cycles from us to run Redshift, what we do is we are continuously monitor your workloads, and every time we find some slack, we find some cycles which we can use, we use it in order to improve the performance of your environment. For example, we might see that we need to run statistics. We run analysis some interesting areas of your tables because the statistics are not fresh and the quality of the query execution plan is not good. Or we decide to run a vacuum on a table because it needs to be vacuumed. Or we might even decide to go and change the physical design of your database if our machine learning algorithms tell us that this is something that would be beneficial for your operation. This is one of my favorite graphs. We have released a new table type, which we call it the auto table. And what we did here is we start running a benchmark, the Cloud Data Warehouse benchmark derived out of TPC-8. We loaded 30 terabytes of data, no design, no physical tuning of the database, and we started running the workload. What you can see is that after a few hours, after 30, 40 hours, by 30, 40 hours, the performance of the system was able to improve by almost 2x. It went from 100 minutes down to 60 minutes. By us observing the workload, changing the design, the physical, the distribution keys, the sort keys, the encodings of the database, in order to get the optimal performance out of that. And we take it to the next level. As of last year, not only we go and change the physical design of the database, but we might even go a step further. We might even go and create materialized views for you because we see that there is a specific report that you are running every morning at 9 a.m. and that can be incrementally maintained. We can go and create it. And if you stop using this report, we go and drop this materialized view. This very active monitoring of the database and effort to improve the performance of the system is something that is making your life easier. And the culmination of our efforts when it comes to autonomics has been the introduction of Redshift serverless. Even though we try to take a lot of the muck out of your day-to-day operations with Redshift, there was still many decisions you had to take about a provision cluster, instance type, size of the cluster, and whatnot. So we rethought a bit how we offer Redshift to you, and since last year we have G8 Redshift serverless, where we have we automatically provision, pause, resume, scale. You pay only for the seconds you are using the Redshift serverless environment, and that's it. And we already have thousands of users using Redshift serverless, and we are getting very positive feedback, and we keep on improving serverless as we speak. For example, last night, I don't know how many of you watched Peter's keynote, Monday night keynote. Up until now, what you had to do in Redshift serverless, you had one knob, which was the base RPU. What is the basic size of the compute we are using for Redshift serverless, and then we auto-scale as demand comes in. But even that sometimes may not be great if you have very large variability in, for example, the sizes of the queries you are running. The RPU size may have to be changed. For example, if you are running big ETL jobs, you may need a larger serverless, but during the day, if you are doing smaller runtime, operational queries that we use very little resources, you may want to use something much, much smaller. So what we do is we use machine learning. Tim Kraska is a colleague of mine. He's also a professor at MIT, working together, and we have used a lot. We have been improving on machine learning and our prediction to try to right size automatically for you the Redshift serverless, and we may even auto-scale in different size serverless environments, all of them in order to try to improve the performance of your workload and minimize your cost. And we actually even have some modes of operation. You can say, hey, I like this right sizing and automatic provisioning, but optimize for cost, have a balanced behavior, or even be aggressive and try to always push for the best performance. The last area where kind of all the previous ones is kind of on the core of the warehouse that we are giving to you. So we have industry-leading security, availability, performance, elasticity on the compute and the storage side, data sharing, autonomic, serverless. But all of that is useless if you cannot ingest and put data into motion, into analytics. So the last area where we're putting a lot of our energy has been around ingesting and put the data and making them available for analytics. As you know, moving data from place A to place B is not an easy task. If you saw even Adam's keynote earlier today, he talked about ETL, and how many of you have not debugged an ETL pipeline that is broken and somebody is yelling at you because the data is stale. And we can have multiple sources of data. We have operational databases, we have streams, we have the lakes, we have even files in S3 that are being dropped here and there. Maintaining this data pipeline is expensive, it is error prone, adds latency from the time the data gets captured to the time the data is available for analysis. So we have put in a lot of our energy in this area. For example, since last reInvent with G8 streaming ingestion, so you can have either your Kinesis KDS or your MSK, your Kafka, managed Kafka environments directly ingesting data into Redshift. We are able to, we see consistently with customers being able to ingest hundreds of megabytes per second per Redshift serverless endpoint or Redshift provision compute environment. And we are able to do that, ingest data at hundreds of megabytes per second with very low latency. And all this data can land in a super data type, and then you typically, because they are coming as logs, click streams, JSON files, and then you can use the super data type to unpack them, do all the schemaless query processing that you can do in order to unfold it, flatten them, and make them available for analysis further upstream. Or we also were still in preview of the autocopy, where you register a location in S3, you start dropping files in there, the system gets, all the data gets ingested. Even more importantly is about operational stores. This is a typical pipeline if you had to move data from an operational system to an analytic system. For example, you have to use something like a CDC system such as DMS, put the data in S3, toss them around with glue, and then go and load them into Redshift. And then you had to do a bunch of processing into Redshift in order to deduplicate the CDC stream in order to end up in a state where you can use the data for analysis. All these things, as I told you earlier, multiple steps, error prone, cost, latency, we don't like all these things. So we took all these things and we tried to throw them away, and we are kind of envisioning a zero ETL future. The idea is to have an easy, secure way to enable near real-time analytics for your most valuable data, your operational data, to Redshift, via Redshift. We did it, and the reason we have been able to achieve this thing is because we kind of own both of the storage layers of many of the very popular operational stores out there. For example, as I told you earlier, we have G8, or the integration between Aurora, MySQL, and Redshift. We did it on the storage layer, and that is a great great win for you because you don't have to have the overhead of, for example, bin log replication on the Aurora MySQL environment. The transfer happens by us on the storage layer, and then we don't have to do a CDC difficult duplication, joins, deletes, and stuff on the analytical side in order to create this, to mirror the data from the Aurora. So it's a triple win, if you will, for you. We G8 Aurora MySQL integration, zero ETL integration with Amazon Redshift, and as of this morning, Adam, in his keynote, he announced that we are starting preview of other 3 very popular data stores for us. In particular, we have added previews for Aurora Postgres, we added support for RDS MySQL, and we added support for DynamoDB to Redshift. And we are excited about that. You can do so many new things with all these operational stores that you can move them effortlessly into Redshift, and we are excited to hear your feedback on that. And you can rest assured that we will keep on adding more of that in the future. So that is my last slide, actually. The way we think about it is I tried to explain to you that we have a very solid, secure, available data warehouse where you can now have the ability to build multi-data warehouse architectures, for example, data meshes or kind of hub and spoke applications. And then we're putting a lot of our energy in the ability to ingest, move the data from all the important sources into this architecture. And one area I did not talk a lot about it has been on the consumption side. We have many sessions, even in this week, where we can talk about it. Swami's keynote tomorrow about Gen AI is there. I suspect that you are going to hear more things about that in Redshift tomorrow. But that's it. Like that's how we think about how you should build your applications in Redshift. And with that, I will ask Francisco to come over and tell us about his experience with the product.
Thanks, Ipo.
Thank you.
Thank you, Ipo, for the kind words. And I'm privileged to be here in the birthday of Redshift exactly 11 years ago. I'm going to tell the story of how Klarna has been using Redshift for 6 years. I want to share the good experiences that will relate with what Ipo has been sharing, but also some of the frustrations we have had. And I want you to take 2 takeaways. One is plan your growth of your data platform to follow your data growth. And the second one is, if you have solved this problem, please reach out because I want to know about that, okay? My name is Francisco. I'm the engineering lead for Klarna's data platform. It's the whole suite of streaming, data lake, data warehouse, BI, and machine learning. But who is Klarna? Klarna is the AI-powered payment network and shopping assistant of the future. Let me unpack this for you. You might know Klarna as a buy now, pay later institution, but we're actually a bank, and we have a massive scale. We're supported by the world-leading investors, and we're the fastest shopping destination in the world. Our customer base is diverse. Essentially, everyone in our most mature markets are using Klarna. 80% of the people in our market use Klarna. Our customers are financially responsible, and they have a really low outstanding debt with Klarna compared to the average credit card balance. Klarna is a global brand. We're truly global. We're top players in the US, we're top player in the EU, and we're growing rapidly elsewhere. And we have a great network of merchants across a range of different categories and verticals. Ultimately, Klarna is on a mission to accelerate commerce. But this is reInvent. We're here to talk about data and technology. So let me jump into the details of how Klarna is using data. For us, data is the core of our business, and we use it daily for thousands of decisions. All dimensions that you can imagine, we use data to make decisions. We use it to build solutions for our customers and our partners. And because we're a bank, we actually have to use data to prevent fraud and to stay compliant. At Klarna, everyone is using data. We encourage everyone from the CXO level to everyone else to feel enabled to work with data, to have a notebook ready to deep dive into the details of the data. We don't want to have data silo of analysts or data engineers. Everyone is entitled to go and look into the data. To have a sense of scale, what we have today in the data platform is a 5 petabyte data warehouse. All of this data is hosted in Redshift. Today, our ETL workload represents approximately 200,000 queries per day. And we're growing in data footprint 35% year over year. Within 2-3 years, we're going to be doubling the size. That's kind of the pattern. Every 2-3 years, we double the data footprint. When working with data, we have very clear expectations. When working with terabyte-sized tables, billions of rows, we want snappy results. We need BI support. We want our dashboard to be extremely responsive. And with this growth that we have, we need the data platform to follow the growth patterns very well. We cannot allow for the data growth to kind of affect how we work with data. Back in 2017, we had a very different setup. We were deployed on premises, and we have a very diverse technology landscape. I don't need to mention Hadoop or anyone else, but at that point in time, we did a level up project to both move to the cloud and simplify. In that simplification stage, we selected Redshift as our strategic partnership among all the kind of data warehouse solutions in the cloud. And we also decided to keep all Klarna's data within Redshift. This is going to be key. All Klarna's data is staying with Redshift. At the beginning, we have streaming data, batches, micro batches, RDBMS snapshots, all kind of data coming into a single Amazon Redshift cluster. And on the other side, we have systems performing ETLs. We had analysts doing ad hoc exploration, and we have dashboard consuming the data. With time, our data grew, and so it did Redshift, until it didn't. There was a point in time when Redshift could not cope with the data growth. When Redshift failed, it was actually quite loud. My users' feedback was clear. They had to wait and complain. And for each message here, it's been anonymized, but I know the person, I know the date, and I know the incident behind this waiting time. Let me put a clear example. I said we are a bank, and we have financial reporting as a requirement. Every now and then, we need to send a report to the regulators. And as I said, all Klarna's data is in Redshift. So we need to build this report using Redshift. When Redshift is slow, we have the risk of failing our obligation. And that's not really an option we want to have. When that is about to happen, this is how my customers feel. It's just resourceless, powerless. They just need to get the job done, but the technology doesn't help. And they don't have any other option. Please help. That's the sentiment. Why were we struggling? Well, in general figures, we were running a lot of queries. We were scanning a lot of data. This is not the data size of the data warehouse, but how much data we were processing every single day. And we have a really big data catalog. It's a lot of tables, a lot of views, a lot of schemas. All that adds complexity, like making the problem of capacity more complicated. To level up, and this is the part where I explain how we help the data platform to grow, and this is the part where if you have other strategies, please reach out. So I have 4 pillars. One of them was to clean waste and revisit the scheduling of our ETLs. Were we running things too frequently? Well, let's fix that. Okay? That will immediately give you some capacity. The second thing is we incorporated in our governance model good practices around ETL and SQL knowledge. So write SQL in a way that is helping Redshift do the work well. And that was embedded in our governance model. And the third step was to incorporate a priority mechanism that ensures the most important jobs goes first always. There's no excuses. The most important, always run. There's no queuing for them. I said 4 steps. The last one was to ask for help. We actually engaged with AWS at all the levels that we could manage. We got executive sponsorship, and we engaged with the Redshift service team, support teams, the account teams, everyone. Basically, the ask was help. We have this context, we have this problem. And our solution, based on all those conversations, was to leverage Amazon Redshift data sharing. As Ipo mentioned, this is the capability of Redshift to use data across different data warehouses. In short, data sharing is designed to allow you to create a data mesh kind of architecture where you isolate compute workloads from each other while enables you to share all the data. And the data mesh is a good dream, but we had to take a first step. Our first step was to go extremely simple, and we decided to go with one main cluster where we process all the ETL, and another cluster that is connected to it used for other kind of workloads. Remember that slide with the fire and the server burning? This was the context then. We have a lot of data. We were scanning 2 petabytes of data daily. After re-architecting and adding data sharing, what we have achieved is 3 times more queries per day. We have double the amount of data processing, and we have even increased our data catalog. All those numbers, they actually don't mean a lot unless we see the effect in our ability to complete our business. So my customers now, they're actually quite kind, and they come to Slack and say, hey, what's going on with Redshift? Things are just working. Great work. And this is the great work of all those 4 pillars. It's the governance model, the cleaning, the priority, but also the partnership with AWS to solve this problem. If I go back to the financial reporting use case, remember we had all our data, but now the reporting is generated on the consumer cluster. This capacity isolation has allowed us to build the report with confidence every time. And again, the feedback from my own customer on this case is great work. They just can't work as they would expect. For us, this is just the first step. And what we will be looking for is to leverage some of the announcements that have been done today. I think we have a clear path on keep using data sharing and leverage the serverless offering for Amazon Redshift. We're going to look into lake formation and the Glue catalog for improved governance. And I think this idea of the zero ETL, trying to remove all the heavy lifting we have to do today to send data to Redshift, that's going to be fantastic. Yeah. And I think that would be all for me. Maybe, Ipu, you want to come back? So thanks, everyone.
Thank you, Francisco. So that's where we are. That's the last slide. Kind of in the past 1 hour, I took you through the history of evolution of Redshift, and Francisco gave his experience. All right, we're at time. Thank you so much.